So, today we're going to do section 3.1, which is the derivative. Yay! That is, we finally arrive at the calculus. The limits are good. I mean, they are the foundation of how calculus is found. But the derivative is the first true calculus subject, right? I mean, so we got to get to it. And of course, first you need to look at this guy. That's Sir Isaac Newton in your textbook. He's the one who invented calculus. So all this awesome stuff that we're about to study, he came up with it. So we need to remember that. There's also another guy, but we will not talk about him because Isaac Newton is the one who not just invented calculus, but he also invented physics. I mean, some of the physics laws, and which I might teach physics someday. Make a class like this. So Isaac Newton is totally cool, and we will just remember him. All right. So so the first thing about calculus that you have to know is called the slope. That the same slope you learned in, I don't know, somewhere in algebra and see it all the time. What is the slope? The slope of something. The slope is like you got a hill of some sort. Here's your hill, here's you standing there. Okay, that's you, and there's your hill. And so this distance is called the rise. And this distance is called the run. It's obvious why this is called rise. I don't know why this is called run. I guess you got to run over there. But anyway, so the slope, which is always called m, I don't know why that is. M, which is the slope, is defined as rise over run. Now, what the slope means is how steep is it. Say if you have a little bit of rise, right? That means it's very, very, it's not much, it's pretty flat, it's level. If you have a lot of rise, then it's very steep. If it's so steep, you might not be able to stand here. You're just going to roll right off. So the bigger the slope is, the steeper it gets. And eventually, if you're completely vertical, your slope goes to infinity. But anyway, that's called a cliff, right? So we are considering the slope, which is the rise over run, and the rise over run in mathematics is also called, if you have 2 points, and let's say this point here is x1, y1, and this point is x2, y2. The slope is also defined as y2 minus y1, that's this distance, over x2 minus x1. Okay, that's the second way of looking at the slope. And the next thing you can look at slope, define the slope. You can talk about the slope in all kinds of ways, right? Now, being that in calculus we call y equals to f of x, right? The slope can also be defined as I'm on page 200 and something, 15. So the slope can also be called this, which is f of x minus f of a over x minus a, where well, f of x is y2 and a is y1. All right, you just have 2 points, and you can call it something, whatever. We have called it different things, but remember, a rose by any other name in math is just as sweet. It's the same thing. And so that is the slope. And there's yet a fourth way of doing this. The fourth way of representing this, saying the same thing, is when you let x. I want x to be x. What? A plus h. Sorry. I want x. Ugh, this looks bad, doesn't it? I want x, let x equal to a plus h. Why? I just do. Okay, so humor me. It's convenient for some ways, but it's the same thing. So x is now a plus h. So your slope formula changes to f of x is a plus h. So you write it in there. And then minus f of a is still itself, right? And divided by a plus x is now a plus h. A plus h minus a. That's just h. Okay, that's the fourth way of saying the same thing. So far, I have represented the slope 4 different ways, but it says exactly the same thing. A slope is rise over run. All right, so so that's good. And there's a name for this thing. Is I guess it's called a difference quotient with increment h. So h is your increment. The word increment means you increased a little bit. See, here you start out a and you incremented a by h, a little bit. So then, yeah, and then you divide it by the increment. Yeah, good enough. So next, we, yeah. So what is that exactly? Well, in a graph, if we were to draw something, you can see what this is doing is that, excuse me. Well, there are various graphs in your book that shows the slope, but you've seen slope before many, many times. So we'll move on to the next definition. But you can look at the graphs if you want. See, I mean, for example, like this one. Yeah, you draw a graph, then you draw the slope of some line on it, right? But let's move on to, so yeah, that's somewhat interesting, but what is the point? Let's get to the next point, okay? The first definition is the tangent line. The tangent line of some point. So the tangent, okay, the slope of a tangent line at a certain point is defined as the limit as x approach a of first this definition. So f of x minus f of a divided by x minus a as x approach a. Now, as you can see, if x approach a, you're dividing by 0. That's what we've been talking about in the last section. The delta epsilon definition, remember? I mean, you cannot divide by 0, but we'll look at not at a itself, but the neighbors around it. We will look at the neighbors, close by neighbors, and see what they do. So that is the slope of the tangent line. Right now I'm in page, this is page 217. All right, so so that's the slope, and this slope will also be written like this. We already wrote it like that. Now let's write it like this, which is also written as the limit as h approach 0. See, if x approach a, h will approach 0, being that there's this relation, x is a plus h. Right? So these are the same thing. X is approaching a, so the difference between x and a will go to 0. And then you write down that formula right here. Copy that whole thing down, limit. Okay, f of a plus h minus f of h. And then you divide by h, and as h approaches 0. And that's the definition of the tangent line. And what does that do in reality? In reality, what happens is that, say you have a graph. I'll draw the graph over here. Okay. Yeah, let's draw a graph. And you have some kind of a function. We'll call it f of x. And there's a here. We'll call this is a. Yeah, a is, okay. So you have a here, and you draw a tangent line a little bit off. This is h, okay, a little bit off. So then there's this is a, and this is a plus h. So and then you draw a tangent line across those 2 points. And if h is a small number, then the tangent line will be close in slope to the original function. As maybe if the function is not too jagged. Okay, if it's too jagged, then that's much harder. But let's say the function is somewhat smooth. So then you can as it gets closer, the limit will hopefully exist. And if it exists, then that will be the slope of your tangent line. The actual tangent line only touches at one point. Like yeah. Anyways, so that's that. If you say, why are we doing this? Like, what's the purpose? And then to consider the point of doing this stuff, and it's we can imagine Newton at the time. What is Newton doing? Why is he inventing these things? Well, I don't know, but I would guess. Okay, is that say he looks at some function, parabola x y equal to x squared, and then you look at this thing. Okay, what is the slope here? In algebra, you can't calculate the slope here because the slope is only defined as rise over run of a straight line, and this is not straight. This is bent. In fact, this is different. This slope here is different from this slope here if it has one, but you can't calculate it because it's changing. There's too much. Like when we in algebra, we are doing a slope with some mountain that's fairly straightforward, not curving all over the place. Nevertheless, you know intuitively that standing here is somewhat okay, right? You're standing here. We're standing here. You are going to fall off because that's very steep. It has a slope, but how do you calculate it? Is Newton's problem. So the way you calculate it is you zoom in into the delta epsilon definition. You look at a very small area, and then you approximate it. Okay, and then a very small area. Then you draw a line that's almost the same thing. You see, and then if you let it go to 0, then it's exactly the same thing. And that is the purpose of the delta epsilon definition. So you find a small neighborhood of delta such that your slope will be within the epsilon error tolerance. So that's that. Okay, now having said all that, let's figure out something about the tangent line. Do an example. This is on page 218. We'll look at the example 3.1. 218, 3.1. All right, which you have, you need to find the equation of the line tangent to the graph of f of x equal to x squared at x equal to 3. So, all right, so your function is f of x equal to x squared, the generic function. And then the point of interest right now is x equal to 3. So, and then you have to find the line tangent to it. So you can draw it quickly. Being that it's just x squared, you should memorize what x squared look like, which is something like this. It touches at 0 because there's nothing else there. And then at 3, so it's something like this. And then, so let's say the point is there. So you need to draw a tangent line. A tangent line only touches a curve like that at only one point normally. All right. So you draw something like that. That's your tangent line. Okay. That's what we're looking for. We need to find the equation of the tangent line. Now, to find the equation of a line, you have to, it's good that you have one point. What point do you have? Well, you have the point where x is equal to 3 and y is 3 squared, which is 9. So you have a point, and now you just need to find the slope. And when you find the slope, then you can use the so-called the point slope formula. And what is the point slope formula? Is you can look that up, or it's similar. The point slope formula is similar to the slope definition. It would be, once you find the slope, which we'll find in a little bit, the point slope formula says that it is equal to y minus the y value divided by x minus the x value. So first you got to remember what the point slope formula is. It's y minus y1 over x minus x1. It's something you did a lot in algebra somewhere. So so now we know that we got to figure out what m is. And to do m, we follow the definition of something. The tangent at some point x equal to 3 equals to the limit as x approach 3 of f of x minus of f of x we'll just write f of x is x squared, so we'll just write that. Of f of x, x squared, minus f of 3 divided by x minus 3. All right. So that's so now we'll calculate the limit, which we did from previous section, previous chapter now, because we're in chapter 3. Yay! And anyway, so that equals, so as x approaches 3, that's x squared minus 9, right? So maybe I should write down f of x to be consistent. Okay, let's write down f of x. Okay, now f of x is x squared, and f of 3 is 3 squared, 9. And then x minus 3. And you notice as x approaches 3, the denominator goes to 0. You see, that is the problem. But luckily, we've learned a trick where this is, you can cancel it, cancel something, cancel the 0 out. That's the goal. And that is, again, difference of squares. So you factor the difference of squares out. So it becomes the plus 3 and minus 3. And then you cancel this out. So all you have then is x plus 3 left. All right. So yeah. So then as x approaches 3, and that's a simple answer of 6. So m equals to 6, which is what we needed before. So the equation is then is 6 equals to 6 times, you move that over, 6 times x minus 3 equals to y minus 9. And that's your equation for the tangent line. And then this equation cleans up a little bit. And which is, should I bother cleaning it up? All right, fine. So to clean up a little bit, get rid of some of the extra numbers. So it will become 6x, okay? And then that's minus 16, minus 18, and then this move over plus 9. So it's just 9. Yeah, minus 9. And that is your answer, and we got it right.